Hi, you guys. Professor Hayes here. I'm here to help you out on completing assignment 7.5 Earth-Sun relationship in the solar angle. So I went ahead and went to the bottom when I hit submit. I put text entry box. Okay. So if you want to do a file upload, that's fine too. So answer the following questions. Refer back to the module readings as much as you need. You may want to have another window open. I found this to be handy. Okay. So what's the latitude receiving tangent rays on the following times of year? All right. Make sure to keep in mind the sun's position for each date. Are these latitudes receiving 24 hours of sunlight or 24 hours of darkness? Okay. So March and September during the equinox. Let's look at our chart here. Okay, our tangent rays, as you can see, March and September during the equinoxes. Okay, well, let's go up here and look. March and September during the equinoxes. Tangent rays, tangent rays. Okay, so that's going to be the poles. North Pole, South Pole. Number 1, A. Poles, north, south. June solstice. Okay, let's go look at June solstice. June solstice, what's receiving the most tangent rays? Well, we can tell by the tilt, the northern hemisphere is pointed, is going to get more tangent rays. Therefore, the Arctic Circle. I'm a little blind, so it helps too. Okay, C. We already know. All right, that's your number 1. Okay, December solstice. You just go ahead and look at it. Here's the sun with its tangent rays. The southern hemisphere is receiving more sunlight. That's why our December solstice is the Antarctic Circle. Okay, let's go to number 2. The amount of incoming solar radiation is determined primarily by the angle at which the sun's rays hit Earth's surface. If sun rays strike the surface at 90 degrees, the sun's energy is concentrated in a small area. Conversely, if the sun's rays strike the Earth at an oblique angle, then the energy is diffused over a larger area. It's more spread out. You may need to look up the locations to see where they are located on Earth. This will give you an idea of their latitude. Then you can better assess the time of year suitable for each location. Okay, I know Nome, Alaska is in the northern hemisphere. So in the northern hemisphere, we need to know where the most insolation is hitting. Where are they getting the most rays? So I know I got to keep that location in my mind. And I'm going to decide whether it's June solstice, December, or the equinoxes. Okay, because that's what it says. List the time of year, June, equinox, or December, that the following locations receive maximum insolation, so most sunlight. Okay, we know this place is in the northern hemisphere. The northern hemisphere is receiving the most sunlight during June solstice. Okay, I'm going to go down, put number 2A. A. All right, let's see what B is. Sydney, Australia. Okay, well, let's think about it. We know where Australia is in the southern hemisphere. Let's go look at our chart. Most tangent rays in the southern hemisphere, right? It wouldn't be here. The northern hemisphere is receiving more sunlight. It wouldn't be here because it's pretty equal. So it's not the equinox. And I'm keeping where Australia is in mind, the southern hemisphere. I'll go down here and put okay. Oops. London, England. Okay. So let's think about where London is. It's in the northern hemisphere. Not as far north as Nome, but it's still pretty far north, more northern than us. And if you need to, look these locations up. So if it's in the northern hemisphere, let's look at my chart here. Again, it's going to be June solstice. I'll go down here and put, okay. All right. You guys have two more. I'm going to let you do those on your own. Okay, now we're going to go on to the next part. All right. So that's number 2. Let's see number 3. Okay. As you recall, an analemma is a chart that allows you to determine the sun's declination for any given day of the year. To determine the declination, locate a day of the year and follow it across the graph to the left-hand side where declination is listed. Okay, so, right, we're on number 3. Using the analemma, answer the following questions. All right, we're only going to do one of these. This is really easy. What is the declination of the sun on the following dates? Indicate whether the declination is north or south. Okay, so September 28th. I'm gonna go right up here and make this bigger because I'm kind of blind. I'm gonna find September 28th. Here's September 20th, 25, 26, 27, 28. I'm gonna follow that over. I'm gonna say approximately 2 degrees. All right, and that's south. Look at, we're south of the equator. So, all right. Number 3, this is A. I'm gonna say 2 degrees south. Okay, that one's easy. We're gonna keep going. All right, so I think you guys won't have any problems with that. Number 4, solar altitude helps us understand the angle at which the sun's rays strike the Earth's surface. Solar altitude is the height of the sun above the horizon. The higher the solar altitude, the more direct the sun's rays. All right, so the higher in the sky the sun is, the more direct the rays are. Solar altitude is determined by the following equation. Your location equals 90 degrees minus the arc distance. So let's see how we do this, okay? So you're gonna come over here, June solstice, 34 degrees. Well, we already know the sun's declination is 23.5. Okay, so what are we on, number 4? I'm gonna go down here. I'm gonna put number 4. June, was it June solstice? Okay. We're figuring for San Bernardino, right? Let's see. Determine the solar altitude at San Bernardino Valley College, 34 degrees north on the events given. The first one is done for you. Okay, so we're doing the second one. We're going to do it exactly the same as the first one. Okay. June solstice, 34 degrees north. To make a little space, our declination is 23.5 degrees again, north. All right. Okay. Then we're going to go over here. And we're going to do 34 minus 23.5. (23.5 degrees). Okay. That equals 10.5. Okay, now we got to take that 10.5 and we got to our 90 degrees minus 10.5 gives us 79.5. Okay, and that's how we do those sections. So I want try December solstice on your own. Make sure to add instead of subtract because now we're working in the southern hemisphere. Okay. So make sure to add here for December. Okay. Number 5. Using your answer from number 4, answer the following question. During which event, June, December, or equinox, will San Bernardino experience the highest solar altitude and maximum insolation? So after you finish these 3, equinox, June, and December, your highest number is going to be the answer to number 5, the highest solar altitude. Okay, so the highest number that you receive over here is going to be your answer here. Okay, so you have to complete the last one to get that. All right, we're going to go on number 6. Using the analemma, calculate the solar altitude at the various locations on the given dates. You will need to look up the latitude of each location. You can search using Google or Google Earth. The first one is done for you. Okay, all we need for these is the first number, the first degree. You don't need the minutes and you don't need the seconds. We're just working with the first degree. So let's go down, let's do Cape Town. Okay. So I gotta know my latitude of Cape Town. I already know because I've already looked it up, is 34 degrees south. So let's go down here. I'm actually doing B. Okay. 34 degrees south. Okay, now I gotta go look up July 30th to see the sun's declination to get this answer right here. So let's go back to the analemma. Oh, forgot my date, July 30th. Okay, July 30th, here we go. Let's follow it across. All right, we're gonna call it 18. 18 degrees north, okay? All right. So we got our latitude, we got our declination. Okay. Now we're going to add 34 and 18. It's going to give us 52 degrees. Okay. That's going to be our arc distance. You see here how they added 47 and 16? You're going to minus that from 90. Okay, here, I'll put this here to help. 34 minus 18. Okay. Now we're going to come over here. We're going to put our arc distance. Okay. Okay, so 90 minus 52. And there we go. There's our solar altitude. All right, so then you can do Quito on your own, Quito, Ecuador. So there are a lot of steps, there are a lot of parts, but just take your time, because if we were actually in class, you'd be in there quite a while. And when you're done, hit submit. All right, I hope this helps you guys.